All right, hello again, everybody. Today we're going to talk about 10.2 part 2. Just like in part 1, we graphed hyperbolas, which consist of two parabola-type curves, sometimes opening up and down, sometimes opening to the left and to the right. But in part 1, the center point was at the origin. Everything was based around the center at the origin, 0, 0. But these today, like it mentions here, the difference is the center is not going to be at the origin. So this will be a good review on how to do hyperbolas in case you were shaky in part 1. And we'll also learn how to handle things if the center is not at the origin 0, 0 and what that looks like in the equation. All right, well, let's take a look. First thing you're going to do, okay, if the equation looks legit, like it should for a hyperbola equation, you have to subtract both fractions on one side. It has to equal the 1, equal to a 1. First thing you do is find the center point. Then you're going to find the center point just like we found the center point on an ellipse. Okay, so the numbers inside the parentheses by the x and the y is what's going to give you your center point coordinates. So the number inside by the x coordinate. Number inside by the y coordinate. But remember, you have to think opposite. So if, for instance, you're subtracting 5, it's really a positive 5. If you're adding 8, it's really a negative 8. Okay? So keep in mind opposite. Just like we saw for the center point of an ellipse. All right, once you get your center point, and then to pretty much do the rest of the hyperbola, you're going to just do the same steps. From part 1. Okay, so some of the steps from part 1, after you get the center point, the remaining steps from part 1, make sure the equation looks correct, that it equals 1, and you have a minus sign for a true hyperbola. Some of the other steps determine if it's going to cross the x-axis or the y-axis, depending on which fraction comes first. Take the square root of the bottom number of the first fraction to see where your two vertices or points are. And we'll review some of those steps when we do our examples below as well. Real quick before we do our examples, one thing right here, if the square root is a decimal, that's okay. So when you go to take the square root of that first bottom number, the first fraction, the bottom number, the denominator, if you get a decimal, it's okay. No big deal. Just approximate, okay? Not everything always works out to be a whole number, okay? So if you get like a square root of 12, just take the square root of 12. 3 point whatever. About 3.4, 3.5, okay? For instance. All right, so here we go. Let's graph a few of these. When you graph these, I want you to show, first of all, obviously show the center point. Also show both vertices like you did in part 1. Also both asymptotes. Remember the asymptotes are just, they represent like an X going through the center point, wherever the center point is. Okay? All right, here we go. Number 1, let's take a look. All right, so we're subtracting and it equals 1, so the equation is good to go. First, let's get the center point. Now, be careful here. X doesn't come first, Y does. So, opposite -2, opposite +1, this is really your X, and that's your Y. So your center point here is 1, -2. Okay, so just be careful of that, guys, because sometimes we'll put Y first. Okay, but your coordinate goes XY. All right? So center point at 1, -2. So when we go to make our graph, there's our center point, okay? Now, what you can do is once you have your center point, you can make your asymptotes. Just a basic asymptote this way and an asymptote that way. Now, from the center point, okay, take a look. Now, we got the center point. Take a look at the equation. Now, the main thing is your first fraction. All right, these curves are going to cross the y-axis because the y comes first, remember. And in an ellipse, that determines whether the curves go like that or like that, remember. So they're going to go like this because those would cross the y-axis. Okay? So take the square root of the bottom number, 4, which is 2. So that means from the center point, you go up 2 and down 2. So here we go. Up 2 from here. Down 2 from here. So these are the points where your curve is going to cross. So you can make your curves. Remember to don't touch the asymptotes. And then you make this curve going through this point. And there you go. There's our graph for number 1. Okay, remember, don't worry. I mean, this 16 gives you information, more specific information and characteristics of the graph, but we are not going to bother with that for now. Okay? We're keeping things simple, basic characteristics and points. All right, so center point, other 2 main vertices points, 2 asymptotes. That's what I want. All right, let's try another one, number 2. All right, now this one does not equal a 1. So if you want, you can divide 3 by 25. So divide both fractions by 25 and also by 25 here. Okay, so now our equation, we have a 1 on the right, which is what we want. These will pretty much cancel. Okay, now you want to keep a 1 on the bottom because you're going to, actually you don't have to here. Normally you might take the square root of it, but you don't have to because it's a second fraction. So you don't have to put the 1. But if this was the first fraction, you would want a 1 here because you would want to take the square root of it. So keep that in mind. All right, over here, 25 on the bottom, nothing reduces, no number coefficient in front to reduce, so keep the 25, and x minus 3 squared. All right, so here we go, center point. The x is going to be positive 3, the y is going to be negative 4. So center point is 3, negative 4, and square root of the first number is 5, and it's going to cross the x-axis. So that hyperbola means that the curves are going to open to the left and right. So from the center point, we're going 5 to the right, 5 to the left. All right, now we're ready to make our graph. All right, so here we go. Center point 3, negative 4, 3 to the right, 4 down. And we're going to, well, if you want, you can make your asymptotes in the shape of an X. And from the center point, you're going 5 to the left, 5 to the right. 1 vertex point there. And 5 to the left. So 1, 2, 3, 4, 5. And you can go ahead and make your curves like such. Make sure you don't cross the asymptotes. And there you go. There is your hyperbola for number 2. All right, guys. That is how you graph a hyperbola and how you deal with the equation with the center not at the origin. 10.2 part 2. Thanks for listening, and I will talk to you all next time. Bye-bye.